Hey guys, today we're gonna talk about the intermediate value theorem. It is pretty easy. As long as you understand continuity and some limits, you're gonna be good to go. The intermediate value theorem, it's pretty easy to explain with a graph. So I'm gonna give you this. Let's suppose we have this function right here, and I'm gonna say this is temperature, okay? This is the temperature of any type of object. Now, of course, something pretty intuitive to think is that if you have a function of temperature, this function should be continuous at every point. Okay? Now, of course, mathematically, that would mean that, remember, both lateral limits approach the same value, and that value is also the function evaluated at that x value. But in more conceptual way, you could also say that temperature has to be a continuous function, because if an object has a temperature, and let's suppose that temperature is going to be, for example, 10, maybe 10 degrees Celsius. I'm not going to add the units right there, but okay, yeah, why not? So you guys have no confusions. Degrees Celsius, okay? So if an object has 10 degrees Celsius, and then it goes up to, let's say, 20 degrees Celsius, you could say that in this interval, there is no breaks or discontinuities in the function. Physically, that makes sense because the objects, if you increase the temperature of an object, it's not like in a specific moment of time, which would be like your x value. It's not like it's going to stop heating, or it's not like it's going to have like an indefinite amount of heat and then go back to a definite amount of heat. It's always going to be a continuous line, okay? So let's suppose, for example, that you start heating this object at t equals 0, okay, at your origin. And now it's going to reach 10 degrees Celsius at let's say 2 minutes. Okay, this is going to be minutes, and this is 2, so you get this. Now let's suppose you reach 20 degrees Celsius at 10 minutes, so you would get something like this. Now, yeah, that's maybe not like a very straight line, but let me fix it. So you should get something like this, maybe some sort of a parabola, for example. Yeah, this could then say that that is a parabola. Let's suppose, just supposing. So basically what this intermediate value theorem states is that if this object, in terms of this example, if this object is in a 10 degrees, or is in this interval between 10 degrees Celsius and 20 degrees, and this function f of t, or f of t time, yes, this function f of t is continuous. Let me write that now in blue so you guys can see. So if this function is continuous, I hate this spelling. So if this function is continuous in the interval, in the 2 minutes and 10 minutes, then there is a number c. I'm going to say that's supposed to be an e like in cursive, but there is a number c, or maybe n, a number n, such that, that's going to be st, such that this number n lies between 20 and 10. And that you can write it as, there is a number n such that f of n is equal to, and now I'm going to define a line that, well, let's suppose it could be a line like this. And I'm going to call this line L. That's an L. Is equal to L. Okay? So basically what we are stating here is that between, and here I need to specify that there's a number n between that interval, between, I'm going to, maybe this is a and b, then a and b, such that a number, in this case we can say n, is equal to a line or an x, a y value or t value for temperature between 20 and 10. Okay, basically what this theorem states is that if there is continuity in this region of the graph, that means that all the values for the function must exist, or all the values that you can have between 10 and 20 must exist or in a definite way, right? Because there is a number n that if you plug it in as an input, you're gonna get an L value that is greater than L or equal and smaller or equal to 20. Okay, if you plug in that number n for that function. So basically this is what the intermediate value theorem states. If you have a region that is continuous, then you can have a input n that gives you a line L between the boundaries or the limits, or yeah, not the limit now so you don't confuse it, between the boundaries of that region. It's pretty simple. That's why it's called an intermediate value, because there is an intermediate value between this region that is continuous. Okay, so if you have a region that is AB and that the function is continuous, then there is a number n as an input that will give you now an output that will be equal to a line in that region, or a value inside that region. Okay, so I hope this makes sense, and I hope that you guys well understood and learned something from this video. It's pretty simple, so hopefully you guys got everything. So see you in the following one.